So let us begin with lecture number 10. Now what we will do is we'll compare all the proposed designs and also we'll give a conclusion to the whatever we have discussed. Now these are the various designs that I have discussed from evolutionary process, right from the 3D trapezoidal transmitter coil antenna towards the tilted receiver coil antenna, right? Now what you can see is clearly if you observe in the 3D trapezoidal transmitter coil antenna, the uniform induced voltage whatever we have received is 55.33%, which is very high. But what is the disadvantage? There is no flux control, that means there is high transmitter losses is there. And also the 3D structure, it is a 3D, being a 3D structure, it is very difficult to practically realize that design. So that is the disadvantage. Because of these disadvantages, irrespective of very good misalignment tolerance, as we can see over here, this design cannot be employed in many practical applications. So whereas the non-uniform cluster turn coil antenna, which is also called design 2, is actually giving a uniform magnetic field region of 60.84%, but uniform mutual inductance region is 14.4%, which is better than the literature planar designs. But the main disadvantage is it doesn't have any flux leakage control. But additional features, if you see, the quality factor is actually improved compared to the literature design from 73.63 to 81.74. So it has a Q assisted algorithm in it. Then next, if you see 2x2 transmitter coil antenna, or we'll call it as N equal to 2 design. So the voltage uniformity factor is 22.65%, which is really better than the previous design. But the problem is, again, there is no flux leakage control. But the additional feature, if you see, the size has been reduced by 19.89% compared to the literary work, with improved misalignment tolerance. Whereas in 3x3 transmitter coil antenna, the uniformity factor is improved by 45.41%. No flux leakage control is one of the big disadvantage in this, and the misalignment tolerance is also improved by 688.36%, which is very, very great. Then finally, if you see the switchable planar distributed multi-coil antenna has a uniform mutual inductance region of 75.5%. So this you can compare with all other designs. This is the best possible uniformity in terms of uniformity factor in terms of mutual inductance. And also it has a leakage flux is a control mechanism, that is the leakage flux is actually controlled. The only additional disadvantage I have to say, that is complexity in the switching circuit. The tilted receiver coil antenna, the uniform mutual inductance region is 32.49%, but here no need of any flux control because my transmitter is only generating magnetic field along the receiver coil, that is it is a concentrated magnetic field, so there is no need of any flux control mechanism is required. But the problem in the additional features we can see, that is it is a 3D receiver structure, it still makes a problem in employing in many practical designs. So this is the the entire summary of all the designs. So if you see the conclusion, the proposed designs surpass the previous efforts to mitigate the lateral misalignment problem by presenting a promising solution using field forming technique using MMSE algorithm to this prevalent problem in WPT systems. So I don't want to say the second conclusion because I haven't explained anything about my measurement setup. A novel I have also discovered a new VNA based measurement system for series, parallel and parallel series compensation topologies, which I will be dealing completely in a separate video, where I will give a complete circuit analysis of all the 4 compensation topologies and also S parameter analysis of all the 4 compensation topologies and what novelty I have bought in that particular design, so that whatever efficiency you are evaluating using a power electronic converters, you will get a similar kind of efficiency using the S parameter based or VNA based measurement setup also, so that you will be understanding. So this conclusion is not for this, but I just want to say so that you can understand that there is something big is going to come in terms of measurement setup also in future, but not in these video lectures. You will not see that. That is completely a different one. So with this I want to conclude this lecture number 10. Thank you.